We're going through some exciting time here. We're going to try to answer all the questions for SPM Trial Exam in Perak 2012. We'll start with paper 1. This is question number 1. Diagram 1 shows the relation between set A and set B. State the range of the relation. Let's take a look at it. We have domain and codomain. Right? This is what we call domain, and this is what we call codomain. So what is range? Range is the image. The image, that means it is in the codomain that is being mapped. Only those that being mapped. So those that being mapped are only P, R, and S. Q is not included. So the answer is range equal to P. What are those items again? P, R, and S. There you go. Alright, number B. The domain of the relation. The domain, yes, as I stated earlier, domain is the first group, okay, and all the elements in it. So that means it's A, B, C, and D. A, B, C, and D. Yeah, there you go. Take a look at C. What is the type of the relation? And let's take a look at the Venn diagram again. Take a look at this. They are all one element in the domain is mapped to one element in the codomain. But there is one image in the codomain that is mapped to two elements in the domain. So that means this is not one-to-one relation, and this is also not many-to-many. This is not one-to-many, but this is not many-to-one. It is many-to-one, sorry, and it is not one-to-many. So this is many-to-one. Many-to-one. There you go. Let's go and proceed to question number 2. Given inverse function x equal to 2x minus y. So let's find f2. Oh yeah, before I proceed, I'd like to go and recognize Joshua Lee. He's the source, or Joshua Lee website is the source of my question papers here. So if you want to get some past questions or trial papers from the whole of Malaysia, most likely the Joshua Lee website has that. Okay, so go and visit that website. The URLs are in my screen right now. So let's go and answer question number 2. I do not know whether now we have enough space. Let's try it out. So let y equal to f prime x equal to 2x minus 5. So then y is equal to 2x minus 5. So let's put only x on the left hand side of the equation, or left hand side of the equal sign. So that makes 2x equal to y plus 5. Alright, how do I do that? Simple. I first put minus 5 over to the left, and anything minus, it will become plus, right? But later on I switch side. I put the 2x on the left and the y plus y on the right. Okay, that will just make it easy for me. And then x is equal to y plus 5 over 2. So this is fy. Fy is y plus 5 over 2. So fx is x plus 5 over 2. So we want to find what f2 is. So f2 is equal to 2 plus 5 over 2, which is 7 over 2. There you go. So let's move on to question number 3. Question number 3. Given the function gx is equal to minus 3x plus 5 and g of x is minus 6x plus minus 7, find a gf minus 2. Let's just get the function gf first. Gf, this is a nested function, equal to minus 6x minus 7. So gf minus 2, that is equal to minus 6, multiple is minus 2. And then minus 7. So So minus 6 and minus 2 will multiply together become 12. So that is 12 minus 7, which is equal to 5. Okay, next question, we want to find fx. Okay, so that because fx is nested in g function now, so let's go and separate it out. How do we do that? Just follow the step here. So now fx is the argument inside function g. So that is minus 6x minus 7. So what is gx? Gx is minus 3. So replace x with function x. Plus 5 equal to minus 6x minus 7. Let's move down a little bit. And what's next? We need to leave only fx function on the left hand side of the equation, left hand side at the equal sign. So we need to transfer the minus 3 and positive 5 to the right hand side. So we need to do anything that with minus and pluses first. Okay, anything that deals with multiply and divide will need to be done at the last stage. So let's go and transfer positive 5 first to the right hand side, so it becomes minus 5 over here. Then f minus 3 fx then is equal to minus 6x minus 7 minus 5, that is minus 12. Okay, now let's go and move minus 3 over to the other side. So if minus 3 is numerator of the left hand side, so if we transfer it to the right, then it becomes denominator. So then fx is equal to minus 6 6x divided by minus 3 is what? Is 2x. And then minus 12 divided by minus 3 is 4, positive 4. There you go. And let's move on to the next question. The quadratic equation 3x squared plus px plus q is equal to 0 and has roots minus 1 and 10 over 3. Find the value of p and q. Interesting question. This carries 3 marks. Okay then. So take a look at the roots there, which means that 3x with squared plus px plus q equal to 0, then that will make it to become x plus 1 multiplied with x minus 10 over 3, okay, equal to 0, because that is the root, right? If minus 1 is the root, then we know that x plus 1 is equal to 0, because if x plus 1 equal to 0, x is minus 1. So that's how we put it back into this format, right? X minus 1 in bracket, and then multiply with x minus 10 over 3, that equal to 0. So that plus 10 over 3 as a root, that will become x minus 10 over 3. So let's multiply both sides with 3. Then we leave this side, okay, x plus 1 as is, and then only the other one that we multiply with 3, which is 3x minus 10 equal to 0. And then let's try to open up this bracket. So that makes it 3x squared plus 3x minus 10x minus 10 equals 0. Okay, so let's go and resolve that. 3x squared plus 3x and minus 10x, that will make it minus 7x and minus 10 equals 0. And this is actually equal to 3x squared plus px plus q is equal to 3x squared minus 7x minus 10. So p then is let's compare that, this value, this and this, right? And then q over here and this value over here. Okay, we need to go and pair up the right coefficient. So p is equal to minus 7 and q is minus 10. Alright, let's move on to the next question. Oh, before we move to the next question, I would like to show you another way to solve this problem. This is one way, okay, this is my own way. There is another way that we can do to also get the same result. Let me just show how to do that, and let me just delete this solution for a while, and I replace that with another way, okay? But this is still valid, okay? This method is still valid, but I just like to go and show you another method to do it. So it will depend on you which way you want to do it, okay? Whichever that suited you most, then that's the way that you should try to you know, whenever you find any similar question, then you can try to solve the question using whatever method that you feel comfortable with. Okay, let's try to do that. Okay, let's do it now. Okay, we know that minus 1 and 10 over 3 is the root. So what is it? What does it mean? If we replace x with the root, like 1 squared minus 1 squared plus px, which is minus p minus 1 plus q, that is equal to 0. So then minus 1 squared is 1, and then multiply with 3, it will become 3 here. And then minus 1 and p become minus p plus q equal to 0. So that means p minus q is equal to 3. How do I get that? Well, yeah, I have cut short a few steps. Let's not do that, otherwise some of you might be confused. Let's just do step by step. Okay, so let's move 3 over to the other side, so it becomes minus 3. So this becomes minus p plus q equal to minus 3. So you can use this equation, or I can also switch all the minus to become plus, and plus become minus. So like this, p, okay, it was minus, now become plus, minus q equal to 3. So you can use any of this equation, it's fine. So I just wanted to select the second one into my equation 1. So I named that equation 1. So let's go and get the second equation, and then we can solve this problem using simultaneous equation method. Alright? And let's put on the second root into the equation. That should also equal to 0. And let's do that now. 3x squared. So what is x now? It's 10 over 3 squared plus p 10 over 3 plus q, that is equal to 0. Alright, then okay, let's multiply both sides with 3, because we want to get rid of the denominator 3 there, so that it makes the equation a lot simpler, okay, a lot less complicated to solve. So multiply both sides with 3. Let's do that in red. Okay, multiply this side with 3. 0 multiplied with 3 becomes 0, and this side is also multiplied with 3. The whole thing, okay, the whole thing, not only 3x squared. So now it becomes 3 squared times with 10 squared over 3 squared. Okay, because 10 over 3 squared is actually equal to 10 squared over 3 squared plus 10p. Okay, because 3 is already gone. Okay, 1 over 3 multiplied with 3 become 1. So now you have only 10 multiplied with p, so it becomes 10p. And then plus 3q. What about right hand side? 0 multiplied by 3 is 0. Okay. Then 3 squared and 3 squared over here, we can cancel each other. So left is only 10 squared, which is 100. So that is 100 plus 10p plus 3q equal to 0. And let's move 100 over to the right hand side. If you notice now that this method is a little longer than the method that I showed you previously, okay, earlier, but this is still workable. The first method is a lot shorter, but it might not be so suitable for you, so choose wisely. Minus 100. Okay. So I named this as equation number 2. So now let's go and solve simultaneous equation. from 1, if p minus q equal to 3, then p is equal to q plus 3. Okay, because I just transfer minus q to over the right hand side, so it becomes plus q. So I name that as 3, then substitute 3 into 2. Okay, let's push down. Okay, that's the problem with this. I don't have enough space. Let's put somewhere else. Let's put small space on the right here. Let's see if I can just shift it a little bit over here. Yeah, you can do that. So 33 into 3 into 2. So what will happen? Then 10p plus 3q is negative 100. So p now is q plus 3. Okay, and then plus 3q, that's equal to minus 100. Alright, so 10q plus 30 plus 3q equal to minus 100. So 10q and 3q become 13q, and then 30, when you transfer to the right hand side, it becomes minus 30. Alright, so okay, 13q now is equal to minus 130. So q is equal to q is minus 130 over 13. That is equal to minus 10. So you still get the same value. And then put q equal to minus 10 into 3 to get the value of p. So p is q plus 3, so minus 10 plus 3, which is p equal to minus 7. There you have it. So both methods works, but the first method is a lot shorter than the second one. So choose wisely. Let's move on to the next question. Diagram 5 shows the graph of quadratic function fx equal to minus 4 in bracket x minus h over 2 squared plus h squared plus 2 plus k. And that's the graph, okay, with the maximum point there. This is smiley face graph, not smiley face, the frowning face or the sad face graph, with the maximum point of 1 over 9, which means that that's the place where dy dx is equal to 0. Because dy dx is the what I call that, the function of the gradient of the curve. Okay, so what is required? The point 19 is the maximum point of the graph fx. Find the value of h and the value of k. Okay, let's take a look at it closely. We need to fx there. I don't think I have enough space here, so I need to go and draw somewhere in the middle. Hopefully it's gonna be looking messy, but I hope you can still make it up and still make sense of the step I will be showing you. You see here, fx minus 4, and then in the bracket x minus h over 2. So we need to break it down. Okay, we need to open up this bracket and break it down. Plus h squared plus 2 plus k. So h and k are two constants. Let's not open up that bracket thing and expand the equation. Let's just go and differentiate right away. So f prime x is equal to 2 multiplied with minus 4, and then x minus h over x to the power of 2 minus 1, and then multiply with the integration of, differentiation of the function in the bracket. Okay, let me just correct a mistake over here. Oops, that h over 2, right? Okay, the differentiation of the function inside the bracket is actually 1. So 2 and minus 4 become minus 8. And then x minus h over 2 to the power of 1, okay, and multiply with 1. So this is how it looks like, and then that will give you the maximum point there at x is equal to 1. You see here, x equal to 1, x equal to 1, f prime x is equal to 0. Remember, f prime x is the differentiation of the function of x. Then f prime x is the function of the gradient of the curve. And at the maximum point, the gradient of the curve is 0. I hope you can see it, okay? That is the tangent of the curve at the maximum point. And that tangent gradient is 0. So f prime x is 0 at x equal to 1. So that means, okay, let me just complete here. F prime x, okay, that means minus 8, 1 minus h over 2 is equal to 0. Okay, then what do we do then? We do this next. X, if we go over to the other side, because x now is numerator, we transfer it to the left hand side, it becomes denominator minus x, so it becomes 0. Then you leave with this, 1 minus h over 2 equal to 0. That means h over 2 is 1, and as such h is equal to 0, right? H is equal to 2, because we transfer 2 to the other side, 2, the denominator here to the other side, it becomes multiplied with 2, because we need to leave only h on the left hand side of the equation, of the equal sign. So this is the answer for h. So what about k? Okay, we can use the point 19 there to go and solve k. Okay, so let's first of all get this. Okay, I need to go and zoom down a little bit so that you can see a little bit clearer, or not a bit clearer, but the whole picture. Okay, now let's simplify the equation slightly. So fx now is equal to minus 4 x minus h over 2 is minus 1 squared plus h squared is still h squared is 2 squared. That means it's 4 plus 2 plus k. Okay, so that is equal to minus 4 x minus 1. Let's just leave this bracket and square things right there, right? 4 plus 2 is 6 plus k. Alright, and then what's next? At point 19, when x is 1, fx is 9, right? Or we can say f1 is equal to 9. Alright, so minus 4, x is 1 minus 1 squared plus 6 plus k, that is equal to 9. Move down. Oh, as usual, we don't have enough space, but okay, 1 minus 1 is 0, multiply with minus 4 becomes 0. And then 6 plus k, let's move plus 6 over to the right hand side. This one, we move it to the right hand side, become minus 6, so that we can find k. So k is 9 minus 6, which is 9 minus 6, which is 3. So that's the answer for h and k. Okay, not so difficult. We'll move to the question number 6. Remember, if you have a difficulty in understanding my steps, you can always repeat this video again, because that's the beauty of my module over here. because it's being done as a video. You don't need to ask me to repeat how I answer the question, but you yourself can control the video. You can move forward, you can move backward as many times as you like. Okay, you can fast forward. It's up to you. So that's the beauty of our technology today. Okay, what's next? Alright, find the range of values of x for. Okay, this is not so difficult, but this carries 3 marks, so it's quite good. But at the same time, let's go and restore the zoom level at 170. Okay, so that we can see clearer, bigger font. There we go. So 40 plus 3x is greater or equal to x times 5 plus 2x. Alright. Okay, this is interesting, huh? Okay, now we need to open up the bracket here. 40 plus 3x greater or equal to 5x plus 2x squared. So, alright, I want to move everything from the left, everything here, right? Everything here, I want to move it to the right hand side, but later I would like to switch. Okay, whatever that is on the right hand side become left hand side. So what will happen? This is what happened. If you cannot follow this, then try it with your own piece of paper. Do it step by step. So now it's 2x squared plus 5x. Okay, that was the original right hand side equation. And then if I transfer 3x joining the 5x over there, that it become minus 3x. Okay, and then minus 40. That is now less than or equal to 0. Okay, it's no longer greater than, because I have changed side now. Okay, I have swapped the location from the inequality sign there. So it becomes less than or equal to 0. So then 2x squared. Okay, my handwriting is not helping. It's never been good. Okay, let me try to write it as nice as possible. Okay, 5x minus 3x is plus 2x minus 40. Okay, let's divide by 2 on both sides of the inequality sign. So that becomes x squared plus x minus 20 minus 20 less than or equal to 0. So if we draw the curve, it will become a smiley face, because the coefficient of x squared is 1, and if this is the x-axis, okay, then it will fall somewhere here, right? Then it says that below is less than 0 or equal, so we are looking for this area. Okay, here is where we want to find, and we want to find these two values here, x1 and x2. What is that value? So we can do that by factorizing that equation, the inequality on the left hand side of the less than or equal to sign. So how to do factorization? Okay, this one needs a lot of practice. So you put x here and x over there. So now you need to think about what multiplies with each other that will make it to become minus 20. So it could be minus 20 plus 1, or minus 1, not plus, okay. Minus 20 multiplied with 1, or minus 10 multiplied with 2, or minus 1 multiplied with 20. Just quite a variety of combinations there, but so that it becomes a little bit complex over here. So it requires some exercise, but at the same time we need to maintain x over here. What does it mean? That means whatever number that we put here, right, when we add it up together, it should become 1, not minus 1, not 10, not nothing else but 1. So what could that be? What could that be? So it must be 5 times 4. Okay, so let's go and put 5 and 4 over here. We haven't decided what sign, whether this is minus or plus, we do not know yet. Okay, but the coefficient of x is 1, so this must be 5, and this must be 4. minus 4. Okay. Say if I try to verify that, okay, if we try to verify that, let's put it like here. X plus 5 multiplied with x minus 4, that is equal to x squared minus 4x plus 5x, and then 5 multiplied with minus 4 become minus 20. Okay, that is x squared minus 4x plus 5x is become x, right, minus 20. So it is correct, the same. Okay, so now we know that x1 is actually this value here, right? X1 is minus 5, but that's the root of the equation. Okay, and this is 4. So now we know the range of x is this range. Okay, that range, which is between 4 and minus 5 inclusive. There you have it. The video now is slightly more than half an hour, so I shall stop here, and I shall continue with question number 7 in the next video. So stay tuned. Bye bye, and till we meet again very soon, I promise.